Hello! In this video, we are going to demonstrate Provengo's model-based testing tool, planning, automation, optimization, and all, on a website that simulates morning routine. The code we'll see here is available on our Tech Demos website. It's under morning. Makes sense? So this is an overview video. We're going to see a lot of features. I won't go into the depth of any of them. This will be done in later videos and tutorials. We'll just see how the tool works in general. Okay, so this is the website that we're going to automate. You see we have a person here, and we can make them wear socks and maybe shoes and a shirt, important, and they can eat cereal and brush their teeth, tidy up, and go out. So this is the general plan and what we're going to automate. So let's look at the project itself. Okay, so first let's look at this Provengo project. This is a regular Provengo project, has all these folders we know. And in the spec folder, we have this main routine. It's currently quite linear. We request all kind of actions like waking up, wearing various items, brushing teeth, eating things, and eventually we tidy up and go out. So if we and provide the path of the project, we see that the system generated a series of events that should take place. This is more of a plan, test plan, than actually executing. We'll look at the automation later on. Unlike other systems, we can also visualize how the test plan will look like. So we're asking the system to analyze this test case and provide it as a PDF. And we can see that indeed it's currently a very linear model. But we can elaborate it to make it more interesting. So first off, let's add all possible ways of dressing up. So I'm using this command called request at any order, and I'm just delivering the, passing it all the actions. And now if we visualize the new model, we have a much more comprehensive testing of how things might work out. Now, any test scenario here begins at the start, at the top, and goes down all the way until we go out. So this is one example of a test case, of a test scenario. Similar to a request at any order, we can, for example, decide to maybe or maybe not eat a mango. So we have this maybe command, and once we add it, we basically split the scenario into two. In one scenario, we eat the mango, and another we don't. These commands are known as splitters, and we'll have a tutorial for this as well. But the overview, 3,000 feet overview, you can see that now we have basically doubled the amount of test scenarios. In one we eat mango, and in another we don't. Okay, let's deal with the actuation now. We take, I'm going to add two actuation files here. And this really enriches the model with actuation data. So we can see that now anytime we take a business decision, for example, eat cereal, the system adds actuation. Next up, let's look at, I'm going to remove the automation, and let's look at a specification bug we have in the test plan. So turns out we allow scenarios where people wear shoes and only then wear socks. So basically wearing socks over the shoes. Weird. So we shouldn't wear socks over shoes. That makes sense. But what does it mean testing-wise, right? So we can either say that we shouldn't test it at all. So we kind of like assume that we shouldn't test this. And to do this, we add this kind of file saying basically we're blocking this wearing shoes until we wore socks. So we basically carve out, just remove this type of scenarios out of the system. And as you can see, we wear socks or pants or shirts. At the beginning, we can't wear shoes, and we can only wear shoes after we wore socks. So we basically removed all these test scenarios. We assume they're invalid. Additionally, we can create what's known as rainy day tests. So when we try to do these illegal actions, we fail. So for example, here we fail wearing shoes, or we may fail wearing shoes before we wore socks, and we may fail wearing socks after we wore shoes. Adding this, you see that the test plan became much more comprehensive, and at the beginning we can wear shirts or fail at wearing shoes, and similarly after we wore shoes, we can fail at wearing socks in multiple places. So this allows us for a comprehensive checking of these rainy scenarios where we check something and we try to do something and we check that the system stops us. Another option that's only available in model-based testing is detecting that there's a problem in the requirements, right? So if a requirement allows us to wear shoes and only then wear socks, it's invalid. In order to detect this, we have this type of file where we wait for shoes, we wait for socks, and we blow up. As you can see, the system automatically detects scenarios where this happens and marks them in a way that allows us to take them to product or anyone who did this, the requirements, and tell them, look, these are the problems, here are the scenarios that blow up. So now we can leave these checks in place to make sure that the specification is correct, and I'm adding these assumptions to carve out the invalid scenarios for now. Okay, so now we have a valid model that's also validated to be okay. So now to make things a bit more interesting, we're going to replace this basic breakfast scenario with something a bit more elaborated. So we have 3 types of breakfast. It's again, this select from command is a bit of a splitter. And we have 3 types of breakfast, right? We have a healthy breakfast, we have a quick breakfast, and a basic breakfast, which has multiple orderings in which we eat our food. So if we visualize this again, we can see that we have a lot of scenarios to check. So let's create an optimal test suite for this. So we want to cover a few goals. We want to cover going out. We want our suite to cover eating cereal, eating banana, and to check out this healthy breakfast thing. So in order to do this, we basically generate a sample of a few scenarios. Okay, so this time it generated 95 scenarios. So we have 95 tests now in over slightly around 2 seconds. And now we create an optimized test suite. This is using the ensemble command. So we're running ensemble, and we generated, as you can see, a test suite of size 10 that has full coverage of all the goals. But because we only have 4 goals here, maybe we can do better, right? So we'll ask for a test suite of size 4. And, well, yeah, still got 100% coverage. But maybe we can do better because not all goals are mutually exclusive. Okay, so if we ask for a test suite size of 2, we still get 100. That's nice. But can we cover all the goals using a single test? Well, no. This is because a healthy breakfast, as we defined it here, does not contain cereal, and cereal and healthy breakfast are both goals we want to cover. So we can't do them together. Therefore, we're going to go again with an optimal test suite of size of 2. And now we can run this in automation as we've seen before. We can generate a test book out of it, manual test book. This again will be covered in depth in later videos, but you can see that we have these manual test books here, automatically generated with all these scripts and all the steps needed. And we can also generate Python scripts if you want to have these tests run by some third party. Again, script generation is something we look into in depth later. We can also do non-Python stuff, but here you can see we generated 2 scenarios that are executable by Python. So this has been a whirlwind tour really of the Provengo system. There's a lot more to see. There's a lot of more depth to go into. But I hope this got your appetite going, basically, and your curiosity running. You can learn more online on our website and in our YouTube channel. And thanks for watching. Hope to see you again soon.